Hey there, seventh grade. Pretty excited about today. We're on challenge 5. This challenge isn't a lot different than challenge 4, so it should be something you're able to pick up pretty quickly and make happen. Again, we're going to be using the gripper to pick up and place the tire tower as we follow a prescribed path. So again, a little bit similar, and this is kind of a jumping off point. So we've done a couple here with the gripper. We're going to move in a different direction for our next challenge, but today we're right here with challenge 5, and pretty excited to see the code you guys write for this one. Pretty excited to see how this works out. So let's go ahead and look at it. Here's what it says. Again, we're going to travel, pick up, travel, and put down. We're going to program the robot to complete challenge 5, and here are the requirements. Number 1, the robot must remain at least partially above the travel line throughout its journey. Number 2, robot must pick up the tire tower from mid-course. Not exactly mid-course, but pretty much mid-course. Uh, and the robot must place the tire tower within the finish box. Has to be in the finish box. Your robot doesn't need to be in the finish box, but your tire tower does need to be in the finish box. Placed in the finish box. Robot must in some way declare victory when it arrives, and the program must include at least 4 different types of coding blocks, which none of you have had too much trouble with. You guys are all doing a pretty good job with that, so pretty happy about that. Let's go ahead and look at the path, and we'll talk a little bit about how this path is different and the same and all those kinds of things, but definitely a little bit of a new challenge. So you'll see we've got dimensions here. Some of those dimensions aren't labeled. I'm going to talk a little bit about why those aren't labeled. It's because they're repeated dimensions, but that's neither here nor there. So we're going to start here, travel 36 centimeters, turn 90 degrees, travel 33 centimeters, pick up the tire tower, and then this is a 33 and this is a 33 also before we finish with 31 centimeters into the finish box. And again, some kind of celebration move there. Again, the circumference of the wheels is the same as it's been, 13.5 centimeters. So if we want to know how to travel or how many rotations of the wheel we need in order to travel 36 centimeters, we're going to take the 36 divided by the 13.5 and get the number that is going to be the number of rotations that we need to travel. So we'll talk about that once we get our program up and running. And again, we're going to see a pretty similar pattern of moving and turning, moving and turning. So that's going to be important. The first thing we're going to do, obviously, is a move tank. So we'll see if we can get one of those to come with us. Oh, it helps if you have the right tool selected. So we're going to get a move tank and drag that in. And again, yours will come in with 50 as the speed of the motors, which is fine. After we move tank, we're going to move steering, right? And the first turn is going to be a 90-degree turn. We've been using 92 as those 90-degree turns, which should be fine. Again, in this situation, we'll take a look at that in a few seconds, but that's the basic concept. So let's go back to that path, and let's look. We're going 36 centimeters. So I'm going to bring in my trusty dusty calculator. Can't do anything, can't do any math without a calculator. No, we could, but it's here. So 36, and we're going to divide that by 13.5 to give us this awful number. And definitely that is not the right number. Oh, I got 3.5. So that's now let's look at that though. How did I know that 10 wasn't the right answer? Well, if I have 36 and I'm dividing it by about half of that number, it shouldn't be 10. That's definitely true. So now let's try that again. Let's clear everything, and we'll go 36 this time, divided by 13.5 equals, there's a number that makes some sense, right? The number is just a little under half. So we're going to go 2.6666 or 2.67 rotations forward to travel that 36 centimeters. So we'll put that right into our program. So number of rotations is 2.67 for that first move forward. Then we got a 92-degree turn. And if we look at our map, we move forward and we turn. Now we're ready to go this 33 centimeters forward. So that's going to be another move tank. So we'll go back here and we'll drag in another move tank. Now, I'm not going to tell you this number of rotations because it's most of the program. Also, this is the thing I've shown you one. You guys have big, powerful brains enough. You can figure out how to find the other ones. And again, I'm not trying to hide anything from you. I've told you exactly what to do. We're going to take 33 divided by the circumference of the wheel, 13.5. That tells us how many times the wheels have to go around in order to travel that distance. I'm just not going to give you that number because you guys are way too smart for me to have to tell you this. So let's go back to our program, and I'm going to put in a dummy number. Now, last time I used a dummy number, some of you actually used the dummy number, which is not what we want. I want you to figure out the number. If you just copy this program, it's not going to work. It's not going to work. So let's make that number something that is utterly ridiculous and could not possibly be the answer. We're going to make it 15.2. Doesn't make sense, but it's definitely not the right number. Don't use it unless you're just watching the end of the video, in which case it's going to make me giggle because you really have no idea what you're doing and definitely are using the wrong number. Anyway, 15.2 is not going to work. You do the math, you figure it out, you'll come up with a good number. I'm sure of it, and I'm excited to see. Now, if we look at our path, once we've gone forward, we've turned and we've gone forward, we're on that tire tower. That tire tower should be within our gripper, right? So the next thing we should do is close and pick up. So the next thing we'll do is we'll bring in a medium motor. And again, we've talked about this before, but I'm going to give it to you once again. In order for that gripper to pick up, it's going to be 2 rotations of the medium motor. So we're going to make that number 2, and that should do the close and pick up. Next thing we're going to do is turn 92 degrees. Control C, Control V. I'm just copying and pasting that in. However, this is a big point. If you take a close look at that path, we turned to the right, and now we should be turning to the left, right? So these turns are alternating, which means this should not be a 92-degree turn, but rather it should be a negative 92-degree turn, right? So we're going negative 92 degrees. Now, the next thing we're doing is we're going to go another one of these, the same distance. So Control C, Control V again, and I'll attach that one right there. And I might as well wire these up so we can see them fully and in their proper state. So again, let's track where we've moved, we turned, we've moved, we picked up, we've moved, excuse me, we turned, and then we've moved again. So that brings us to move, turn, pick up, turn, move right here. So we've got to turn again, move again, turn again, and then move and put down. So let's just focus on what's next, right? So we're here, we're going to turn, and again, it's a turn to the right. So that should be 92, not negative 92 this time. So I'm going to go back to my program, and I'm going to think a little bit. I know I need to turn and then go forward the same distance again. So if I highlight these 2 blocks right there and Control C, Control V, I'm just copying and pasting those blocks so I don't have to modify them over and over again. This is a 92, right? So I go 92 degrees, and then I go negative 92, and this time I'm going back to 92. And again, it's the same distance. All 3 of these runs are the same distance. So I'm here. I've gone forward another time. Let's take a look. So we were here, we turned and we went forward. So I got to turn again a negative 92 and then go forward for 31 centimeters. So I'm going to have to do some division again to figure out that 31 centimeters forward and then put that down, put the tire tower down. I could also keep in mind this 31 centimeters goes right here to the edge. So if I want to take another 15 centimeters to get into the middle of the box when I set that tire tower down, I'm not going to tell you not to do that. In fact, in a lot of ways, that makes some sense. It's a matter of how you want to make sure this program works for you, and that's going to be pretty important. So again, 31 plus 15 would give you about 46. If you wanted to take 46 divided by 13.5 to give you the number of rotations to the middle of the box, there's some reason to do that. You could also just do that 31 and hope that you're right there at the edge, but far enough into it that it sets down in the box, which probably will be the case. At any rate, you're going to go forward. That way we're going to turn and then go forward again. Again, this is a negative 92 and then a move forward. So I'm going to Control C, Control V, copy and paste that again. Scroll down just a little bit. Look at that. I actually got it. And then we'll wire this in. And this should be, this number is going to be a little bit different. So we'll put in a different dummy number, which will make every bit, will still not make any sense. 46.13. I didn't even type the numbers that I said. So again, that's a dummy number, not going to work. Make sure you come up with the correct number and put that into your program. Not difficult to do, just a tiny little bit of division. Once we're there, right? So right now, if we take a look, we've moved, turned, moved, picked up, turned, moved, turned, moved, turned, moved. We're there. We got to put down the tire tower and then do some kind of celebration. So I'm bringing in my medium motor. And again, this time it's not going to be 2 rotations, so we got to undo that 2. And how do we undo 2? -2. So we're going to go -2 rotations to put down the tire tower. And then I need my celebration. I'm gonna keep it simple because look at all this code I've already written. I'm going to the tried and true, of course, I don't know if you heard that or not, but the most excellent of all celebration moves, the elephant call, or something awesome that you come up with, which is probably better than that. And keep in mind, you can use your loops to make your celebration even more annoying or wonderful. And all these other blocks are available to you. But right now, I've got 1, 2, 3, 4 different kinds of coding blocks. And this path should work as long as I've followed through and made sure that I've been careful about making sure each of those moves are exactly what they should be. Again, dummy number, dummy number. Nope, right. Dummy number, dummy number. Do not use those numbers. It won't work. They are not the correct numbers. And if they're what you put in, it's because you didn't watch the whole video, which will make me chuckle a little bit, but also won't help you get the right answers. So excited to see the programs you guys write. Take your time, do it carefully. Make sure that you get those correct values for your numbers of rotations, and then make this program every bit as awesome as I know you can make it. Screenshot of the program goes in the exit ticket, submit that exit ticket, and we'll take a look, get that program written for the next class. Excited to see how well your robot follows the path that it's laid out in front of it. Have a great day. We'll see you guys soon. That's it for today. Get that program written. We'll roll.